statements in your own program, you just access a memory array, which means that your read and write do not intervene with the kernel accessing the physical device. So you don't compete with the kernel about access to the physical device. When you map the file, you say, okay, I'll never do physical accesses to the file. I leave that to the kernel. So the kernel will be the only part of the system which are actually accessing the physical device. If that was your question, you save a lot of physical operations and leave that physical operation from the device to the kernel instead of including your own input-output systems. Because normally you would say, okay, when we are accessing the disk, we have a number of, then this would be a request queue, a queue of requests for the disk write, and we know that the disk is rather slow. So if this one contains private access, your program accessing the file as well as the kernel accessing the file, there's no strategy by which the kernel can control what you're doing in your program. But if you say, okay, I'll never do that, I'll leave everything to the kernel, then the kernel can put up the best strategy for handling the queue. That's the explanation why it's more efficient to access the files through memory map files rather than through read and write statements in your own program. So you gain quite a bit of I/O performance by leaving every I/O operation to the kernel rather than competing with the kernel for the I/O system to serve your requests. If that makes any sense to you, that's the idea. So, and then again, by mapping a file like this and sharing that memory with another process, we have now two programs which are allowed to work on the same file at the same time. Why could that be used? Very conveniently. Well, if this whole file was a compiler, this allows you to have shared code in all your programs. So when you have shared objects in your programs, that actually means that you just load the driver or the compiler in one instance, and then all programs wanting to use that compiler will use the same piece of code. So shared libraries are actually implemented through shared memory. In some sense, you load the. What is this shared object? Windows? Do you know shared objects in Windows? DLL objects, which means that they are accessible by several programs at the same time, and you only load the object when you need it. So that means that it's put into shared memory. So if several processes is using the same DLL, you only have that DLL loaded once, and all the programs are using the same object, which is code, of course. If it was data, you cannot share it, but code can be shared that way. So shared objects, or in Windows, DLLs are using shared memory. Shared libraries and shared memory go hand in hand, but you can use it for your own code as well. Yeah, sockets. What is socket? Where do you use it? communicating over networks, yes. So what is a socket?
But what we see as a programmer is a buffer, I think, to me.
Yes, but as it has to connect processes on potentially different computers, and the program do not care about that when it's communicating. The socket must represent the processes on the computer. So the socket will have to contain source ID, destination ID, so that will be an IP address of the source and destination. And what else?
Port.
A port? Yes. Because the port is, no, yeah. What else? What is that? UDP or TCP?
Protocol.
The protocol. So the socket represents or is a data structure identifying the sender, the receiver, the port we're using for communication, and the protocol we are using to send the data. So that's basically a socket. So, and that socket is identified by a socket ID. This is not a socket ID. This is the source address, destination address. So a socket ID, and then you can do read socket ID into a buffer or write socket ID, and then the data you're going to write into that socket ID. So now you can use the same read and write. What about synchronization? What if you do a read in the receiving process before you do a write in the sending process?
Doesn't it work a lot like a pipe?
It works like a pipe. So the socket is just a pipe running over the network, except that it can be two-directional, so you can read and write on the same socket number. So you can send data and you can receive data through the same socket. That's the only difference actually between the socket and the pipe. Which also means that you could actually create a pipe between processes on two different computers by redirecting the pipe to a socket. Then two different computers would be allowed to communicate through pipes, because you have redirected the pipe into a socket. Yes, message queues we had, signals we had. So the special thing about signals is what? How do we communicate through signals? Well, we use we do a signal of some kind, sending a signal. How is the receiving process getting that signal?
Isn't it the kernel that notifies it?
That notifies it, exactly. And how can a process be notified? Because if you do not have a read to read the signal, how on earth can you get that signal?
You register for a signal.
Exactly. So a signal and a signal handler go hand in hand. You register a process wanting to receive signals, register a signal handler. We call it the Hollywood principle. So you go into the door and say, I would like to communicate with you, and then the guy at the office says, okay, don't call us, we'll call you. So you never have to do a read and write, but you have to be ready to pick up the phone when somebody calls you. So that's why we have to register the handler. So you leave, so to say, you leave your telephone number and say, okay, if you have got something for me, then call me back. And if you're never called, well, the handler will never be activated. So it's actually a little bit like the try-catch mechanism in a program where you try for a specific event, and if it's there, you catch it and have a piece of code dealing with that event or that exception. So register the handler, and that's why it's a very efficient way, because the handler is not activated unless the event actually takes place. So you register the handler,